So what was Perceptron? Perceptron was basically built upon the MCP, which was a mathematical model. So what scientists did was they took the inspiration from neuron, artificial neuron, and MCP, and they built the basic unit of the neural network, which is Perceptron. But first, let's see how does the Perceptron work. So basically, we train a simple Perceptron by multiplying the weights, that is the W, and the input, that is the X, and taking the summation, considering all the biases, and then we calculate our Z. Putting this Z into some activation function gives us two values. It could be 1, 0, it could be -1 and 1 according to the requirements. And after putting those values, we calculate some expected values. Expected values, that is the model is going to predict. But are those correct or not, we don't know yet. So what we do, we check them because our data is labeled, so we know the answer. So we subtract it and check if there is an error. We take it into the account, we multiply it with the learning rate, and then we update our weights. So why we update our weights? So we update our weights to get the loss or the cost function as minimum as possible, because that will be taking my model to a higher accuracy. So that is precisely how a perceptron works. It is, but perceptron's downfall started in the AI winter, where the scientists discovered that perceptron cannot classify all the things. What are those? The perceptron was only good at classifying the data which was linearly separable. If the data is not linearly separable, the perceptron cannot handle it. There is a good example like XOR. In the XOR, when we plot it, we cannot draw a line which passes through all the points or which can classify zeros and ones. So this was a prime example due to which suddenly the interest in deep learning goes down, and other algorithms like SVM got very famous. So it was a AI winter. We can't also use gradient descent or backpropagation in this because we don't have a layer. It's just a perceptron, so we can't propagate it very deeply into our network, and it cannot understand the complex patterns. That was a huge disadvantage of the perceptron, although it acted as a fundamental base of a neural network or deep learning. Here I have given an example that how linear separable data can be easily classified by the perceptron, and on the right side, a non-linear data which is not which can't be classified by our perceptron. This was an example I have given in the slide. Next slide. Here we can clearly see I have pasted two truth tables. The first truth table is of AND gate, where you can see we can pass a line which is almost passing through the data points, which we can which is the proof that yes, a perceptron is basically an hyperplane. Hyperplane means if we have n parameters, n-1 is the degree of the hyperplane. If that hyperplane cuts the classes into a half so that we can divide it, that is what a linearly separable means. And on the right side, we have a XOR, classic XOR example, and I can't draw a line which is passed through all the points.